Hello and welcome to section 1.2, day 2. We are going to look at the Pythagorean theorem and the distance formula. I know there will be a handful of you who skipped a section. If you were in the middle class in 6th grade and then jumped ahead to algebra the next year, you probably did not see the Pythagorean theorem, so please listen up. The Pythagorean theorem works in all right triangles, and we will be using it a lot this year. In a nutshell, for those of you who did do it before but can't quite remember, it's your a squared plus b squared is equal to c squared. I'm going to show you first on a coordinate plane. So if we draw our coordinate plane, we know this is our y-axis, and we know this is our x-axis. So let's say I have a point here, A, and the coordinates we're just going to call x1, y1. And I have a point here, B, and we're going to say that the coordinates here are x2, y2. If I want to find the distance between them, then I can make a right triangle out of it, and this is a huge concept in pre-algebra, and I can put point C right here. Well, point C is going to go the same distance on the x-axis, so that means that it has an x-coordinate of x1, and then to go up along the y, it's going to go the same distance up as the b, so it's going to have y2 as my y-coordinate. So now I have a right triangle, and if I want to find the length of this, I can easily count or mathematically figure out the length of AC, and I can figure out the length of BC. So, and the reason I couldn't here is because neither of these are the same. But the length of AC, if I look here, my x-coordinates are the same, so I just have to figure out the difference, the absolute value of the difference of my y-coordinates. So just like we talked about yesterday, if I take y2 minus y1, I will have the length of AC. To figure out the length of CB, I just find the absolute value of the difference of my x's. So x2 minus x1. And my Pythagorean theorem states that a squared plus b squared is equal to c squared. Well, my lowercase a is the length of the segment across from point A. My lowercase b is the length of the segment across from my point B, and my lowercase c is across from there. So I'm trying to figure out basically the length of that segment right there. Well, if I look here, I know that A is the absolute value of x squared, the absolute value of x2 minus x1. And I need to square that value, so I'm going to put that in parentheses. This side is y2 minus y1, the absolute value of that. But for the Pythagorean theorem, we have to square it. And I know that my c is the length of AB, and I have to square that. So the length of this side squared plus the length of this side squared is going to equal the length of c squared. Well, if I look at this, anytime I square something, I'm going to end up positive anyways. So this is a lot of extra information here that's really not necessary. So we can rewrite this as saying just x2 minus x1 squared, because anytime, once again, anytime we square something, we're going to end up positive. So it's pretty much redundant to have the absolute value in there. And then I'm going to have y2 minus y1 quantity squared is equal to the length of AB squared. Now, we talked the other day that it doesn't matter which order these are in. So if somebody had said x1 minus x2, that's going to be the same value at the end. Well, to figure out the length of AB, I have to square root both sides. So if I square root this, I'm going to have x2 minus x1 quantity squared plus y2 minus y1 quantity squared is equal to the length of AB. You're going to look at that at first and you're going to say, that's a whole lot of work. And let me show you when it's simple. And this is what most of you did in 6th grade. If I look here, These two are called the legs. They're the legs because they're the two sides up that make the right angle. So if I take 7 squared plus 8 squared, I'm going to get the hypotenuse. The hypotenuse is always the side across from the right angle. So that's going to equal c squared. Well, 7 squared is 49, 8 squared is 64, is equal to c squared. If I add these together, I'm going to get 113 is equal to c squared, and then I need to square root both sides. So that's when you pull out your calculator. Let me show you something real quick just to make sure you're aware of this. If you had done your 49 plus 64 on your calculator to get the 113, and we needed to square root that, square root key is in blue. To access anything in blue, you need that blue second key. 113 is super easy to retype in, but let's say it was a more difficult number. If you look down here above the negative sign in blue, it says answer. So if I want to go to the very last answer, I can do second answer, and it's going to take the last answer, and it'll square root it for me. And once again, it'll come in really handy if it's something that's longer like this that you don't want to have to type in. If we round this to the nearest tenth, we're going to get 10 and 6/10. So the length of C is 10 and 6/10. Whenever you do the Pythagorean theorem, whenever you have any right triangle, the two legs will always be shorter than the hypotenuse. The hypotenuse will always have to be the longest side. If you need more refresher on the Pythagorean theorem, or if you had never done it before, just come to tutorials and we'll take care of it. We are going to use that concept when we talk about the distance formula. So we're going to use the Pythagorean theorem to help us find the distance between any given points. So if point P has the coordinates x1, y1, and Q has the coordinates x2, y2, then the distance from P to Q can be found using the distance formula. So all we're going to do here is we're going to take the square root, and we are going to take the difference of our x's, so x2 minus x1 quantity squared, plus the difference of our y's, quantity squared. Basically, all we did is we formed a right triangle, just like we did above. So this distance formula is going to be used a lot. So the distance from P to Q is the same as the length of segment PQ. All right, so just putting that into here, we have the length of PQ is x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Example 2, find the distance between points C, which is the point -4, -6, and D should be the point 5, -1. So we have 5, -1. Well, if you look at it on a graph, it's easy to count and say, hey, that's 9 units and that's 5 units. So we can just say 5 squared plus 9 squared is equal to c squared. So 25 plus 81 is equal to c squared. We get 106 is equal to c squared. Square root 106, and we will get 10 and 3/10. Now, if you didn't have it drawn on the picture and you were just given those, you would use the distance formula. So you would say the distance is the difference of our x's. It does not matter which you put first. So I'm going to start here. 5 minus -4 quantity squared plus the difference of our y's. -1 minus -6 quantity squared. Well, we know 5 minus -4 is 9, so we would have 9 squared. We know -1 minus -6 is 5, so we would have 5 squared. Well, look at this. We have the exact same thing. So it's easy if you have the picture to just count, but if you don't feel like drawing the picture, this is also just as easy. So we're still going to get the square root of 25 plus 81, which would be the square root of 106, which is 10 and 6/10. All right, so now push pause and you try one. Okay, so if we want to find the distance between these 2 points, we need to look at the difference of our x's. Once again, it does not matter which way you wrote it. You could have written 9 minus 2 quantity squared or 2 minus 9. And then we want to look at the difference of our y's. So we have 4 minus 5 quantity squared. So when we look at this, we know 9 minus 2 is 7. 7 squared is 49. We know 4 minus 5 is negative 1. Negative 1 squared is 1. So we have 49 plus 1 is square root of 50. I've done this on my calculator already. So I know we're going to get 7 1/10. And that is it. Thank you.